show that for all positive integers n and complex numbers z, where theta is between 0 and pi by 2, that z to the n minus cis theta multiplied by z to the n plus cis negative theta is equal to this. I'm going to do this just by starting with the left-hand side, expanding out, and seeing what we get. So we've got z to the n minus cis theta, and we've got z to the n plus cis negative theta. So let's expand out. So we've got z to the 2n. Take away cis theta z to the n plus cis negative theta z to the n. Take away cis theta cis negative theta. So that is z to the 2n. Take away z to the n into cos theta plus I sine theta plus z to the n into cos negative theta plus I sine negative theta. And then here, remember what happens when we multiply complex numbers. We're just going to add the arguments. So that's going to give us cis theta add negative theta. So we've got z to the 2n. Then we have minus z to the n cos theta minus z to the n I sine theta plus z to the n cos negative theta plus z to the n I sine negative theta. And at the end here we have take away cis 0. Now we know that the cosine is an even function and this one is an odd function. So that's going to be z to the 2n. Take away z to the n cos theta. Take away z to the n I sine theta. And then this one is going to be plus z to the n cos theta, because it's an even function. So cos negative theta is equal to cos theta. But the other one will become take away z to the n I sine theta, because sine is an odd function. And then we just got the take away 1 on the ends. Remember, cis 0 is just 1. So what we've got now is that these cosines are going to cancel out. So we have z to the 2n. Then we've got 2 lots of the I sine theta zn. Take away 1 as required. Hence, using the result from part A, obtain all solutions to the equation given here in exact polar form. Now, note that in part A we had z to the 2n. Take away 2I sine theta z to the n, take away 1. So n is equal to 3, which gives us z to the 6. Take away 2I sine theta z cubed, take away 1. And then if we compare here with here, we must have that sine theta is equal to 1/2. And that would give us that theta is equal to pi by 6. And we go back up here, it did say that theta was between 0 and pi by 2. So I only need the theta is equal to pi by 6. So now let's use the factorization. From part A, we'll get z cubed take away cis pi by 6 and z cubed plus cis negative pi by 6. And that's going to be equal to 0. So we can have that z cubed is equal to cis pi by 6 plus 2n pi, or that z cubed is equal to negative cis negative pi by 6 plus 2n pi, where n is an integer. Okay, so z is going to be cis pi by 18 plus 2n pi by 3, which is 12n pi by 18, or the z cubed is equal to cis 5 pi by 6 plus 2n pi. Just to explain that, the angle was negative pi by 6, which is down here, and then we were doing the negative of that, which would be up over here, giving us this argument as 5 pi by 6. And so I can produce from there that z is cis 5 pi by 18 plus 12n pi by 18. And now it's just a case of using various values of n. So if we go from this one here, we'll get cis pi by 18, that's using n equals 0. Then n equals 1 gives us cis 13 pi by 18. And using n equals negative 1, we're going to get cis negative 11 pi by 18. And then if we use this one over here, we're going to get cis 5 pi by 18. N equals 1 gives me cis 17 pi by 18. And n equals negative 1 gives me cis negative 7 pi by 18.